Welcome to the second session of the IT Systems and Logistics course. The topic of this video is the Mountain Dew game, and we will talk about the analysis of the game. So this session is about the dynamics in the supply chain and the analysis of the game. Our course overview is as follows. We are now at session 2, so we are looking at seeing what has happened during the game, and to this point you should have tried out to play the game online. In the groups you have some instructions for it in the slides update of the session 1. So please have a look at them and play the game in your groups before you watch this video. The exercises of today's labs then are the questions that are at the last lecture slide of the last slide of this lectures, and most probably some MCQ questions. So when we look at the game and how it should have played, we recall the general rule of the game is that the game runs in weeks, and it starts in week 1, and every time and every week each of the group members have to decide what to do. So basically when you play the game online, then you will receive some deliveries from your suppliers. You will update the play sheet that will be also given to you in the Excel sheet that you should analyze also for the assignment. This one is played, or the Excel sheet is filled with data that I will explain in the following as well. And it is from a game that I played in order to provide some data that then you can analyze. The effects of the game played by me, or the online game that you will experience when it works, are exactly the same. So you have deliveries that come in, and you will receive orders from your customers, and you will update the playing sheet. In the online game, it updates itself automatically and registers the data for yourself, and afterwards you can have a look at them in the performance graph. And then you calculate in the Excel sheet the total amount that will be shipped. So you prepare the delivery, note down the amount, how much you ship, and then place it in the box in a kind of an envelope in a box if you play it in real, then you have a table. If you play it online, then you have a kind of a post box there as well in the web page. And then you need, and this one is important, within your group, you need to discuss how much of amount you want to place for the item. Then you note down the number, and in the online game you note it in the field and send it. And if it were in real person face to face, then you would put it on an envelope in the outbox field. So that is exactly the same with the online game. So interpretations now. The problem, the challenge in this game is that the deliveries lead time is 2 weeks. So for 2 weeks that you order, so 2 rounds of weeks, the items are on the road. So if you order, for instance, in week 1, 10 items, then you would just receive them at the beginning of week 4. And this is what you have to take into consideration when you order, that you receive an order from your customer, and also deliveries from your suppliers, and then you have to decide how much to order from your suppliers in the next week, and considering that this takes 2 weeks to come to you. So there is a time gap that can be tricky. If you look at the sheet so the Excel sheet that I provided to you, you have a sheet in this Excel file for every supply chain partner. So you have the retailer, You have the wholesaler, the distributor, and also the factory sheet. And this Excel sheet works exactly the same as the online game. So you have an incoming delivery at the first week that you see here. You don't have an incoming inventory. You have 15 entities, when we look at the retailer, of course, in stock. And then you can decide upon the new order, and these together with the deliveries, so it's 5 units, together with it, it's also 5 units. You have no back order, and you have still 10 units in inventory available, and this is the cost. And now the costs here are different to the costs in the online game. But that is just a number. For the inventory costs, it's 0.5 euros, and for the back ordering costs is 1 euro. So it's double for back ordering and the half, let's say, for inventory. So never mind the cost at the moment. And then, for instance, here I decide to place an order of 5 units for the next time. So these 5 units then are a new order to the wholesaler. When we look at his first week, incoming delivery is also 0. Available and incoming is 15 units still. So now he gets a new order of 5 units, and this together with the TS, that means TS here to ship, is 5 units. So the new order plus something that was in backlog that would have been to be shipped as well. This is 0, so this remains 5. Back ordering is 0, as I just said. And the available and incoming stock was 15 units. After we shipped out 5 units, we have remaining 10 units, and this is just the costs. So this is now here the decision of the wholesaler. The decision is to order 10 units, and this is then the new order or incoming order for the distributor. And this is how it goes on. So the important decision to be taken is the order. That is once again exactly the same as in the online game. And here, because we received an order of 10 units, the distributor wanted to go on the safe side and order a little bit more than the incoming order. So he orders 20, and these 20 is then the incoming order for the factory. Same situation here. Incoming delivery was 0, available and incoming units for every supply chain partner was 15 units. Now the incoming order is 20 here. So the delivery to ship plus new order was 15 and or is 20, but together with the new order to ship, it's -5, and this is the -5 that goes then into the back order, because we cannot deliver everything. We just have the 15 units in stock, and this is why we ship out the 15 units that we have, and then we need to note the 5 units into the backlog. And we get also the cost for the backlogging then in the total costs here. So this time, and you will realize when you play the game online, that there are 2 steps for the factory, because the factory does not have a place where they procure items, so they are building the items or manufacturing the items. So they have a kind of a two-stage system that you will see also in the online game. So in order now, you can see that the factory is already at a backlog of -5. So to be on the safe side, I decided to order in the manufacturing process 60 units. And then this is how it goes on. So you will see here also at that stage, I noted the whole incoming deliveries and the new orders. And if you start from the retailer here, as depicted in the table version of it, you will find all the numbers available that we have seen in the different parts. So, for instance, do I have them somewhere here? No, you can check this in the previous slides of session 1, where the meaning of the fields. But we have the orders, and then this is the decision how much to order at the supplier, and this order is then noted in the incoming at the new order placement field. So it was 5 for the wholesaler, and the wholesaler's decision is then to order 10 units, and this is the 10 units over here, and this one is then the incoming order or the new order for the distributor, and the distributor here decides then to order 20, so you find here the 20 once again, etc. So you see already that here are noted the inventories, so the stocks of each supply chain partner, and you see that here it's still positive, but then for the factory already in week 1 this number becomes negative. And if we go on, so here this is week 2, then things become to get a little bit worse. If we look at the retailer and we start looking here, so in the second week for the retailer still everything is fine. Incoming delivery is 0 because we are in week 2, and everything that we order will arrive, that we order in week 1 will arrive in week 4. So here we have no incoming deliveries. We have still 10 units of items in stock. We receive a new order that is 5 units. So the deliveries to ship plus the new order is 5, and so we have backlogging is still 0. We have 5 items still in inventory. This is the related cost, and we decide to order 5. So 5 went out to our customer, and we just decide to order the same, so 5 units. This is the new order then for the wholesaler, and so on. So this is the decision here, and I speed up a little bit with the numbers. The wholesaler now has still 5 units into stock. He received 5 units of a new order. So he decides, in order to fill a little bit of inventory, to order 10 units. This is then the number for the distributor. He had still 5 units in inventory, no incoming delivery so far because the items are still on the road. So he gets an order of 10 units, and that means that he can ship out the 5 units that are still on stock, but the other 5 units that he cannot deliver become backlogs. So he gets the backlogging costs here as well, and now he is on the backlogging, which is very unsatisfactory. So the distributor, decides to order a lot, so he increases his order to 40 units. And these are the ones that are depicted then here. And for the factory in week 2, everything becomes already difficult because still no incoming deliveries. The factory has 0 available units, so he needs to note this new order of 40 units to the 5 that were already in backlog. So he goes into backlog of 45 units. And this is very expensive that you see here. So once again, in order to be on the safe side, I decided to manufacture a little bit more. And so the factory decides to manufacture 165 units of the product. And this is how, this once again you see here, how this is going on to the different numbers. And you see here, the retailer still has inventory, also the wholesaler, but the distributor has a slight backlog already, and the factory really has problems with the items. And this is how it goes on. So once again, decisions to be made, etc. And now we see that this is week 3, that things become really difficult, because if you look at the inventories, then you will see that only the retailer does not have a backlog, but everybody else is already in deep backlogs. And this becomes then worse and worse. And here in week 4, as I said, we have the first deliveries for every one of the players. So for the retailer, still the inventory is 0. And here now the backlogs can be filled, but not as much as the backlogs increase, let's say, because you see that here the orders become bigger and bigger, and this means also that the backlogs increase despite the deliveries, but they are in confrontation to the backlog quite small in volume, and this is why they cannot fill it up. Yeah. So you see also here in week 5, still the retailer is fine with his inventories. They are 0, but he has not accumulated a backlog. For the wholesaler, the backlog is at minus 60, or at 60. So this is quite a lot. And also for the distributors, you see that the numbers are really bad. And for the factory, they are worst. And week 6 goes on, and you'll see that the decisions that I made for the different supply chain partners really increase a lot. And if you look at the confrontation of the customer demand that comes in at the retailer, you see it here. So the orders are quite regular. I go back now in the weeks to show you that for the first 4 weeks, we have a continuous demand for the end customer of 5 units, and then in week 6 it becomes 10 units, but it's quite stable. So that is not an explanation why the numbers for the other supply chain partners upstreams the supply chain go up that much. And you see here that for the factory, the order at week 6 is already at 1,000 units, because you see the backlog in this week is already at 600, and this is major. And this increases in the trend. I think, I played the game until week 8. In the online game, you will play a lot more rounds to see this effect, but I can show it to you until week 8. So if we see now the depiction of the orders with respect to all the supply chain partners, and please disregard this part. This is filled in the Excel sheet, but I haven't played it just until week 8. So you have to look just at this part of the graph. Then you will see that things really go bad. So you have the order sizes for the retailer in red, and they are quite okay. So these are our 5 units, then it goes up to 10. So for him, everything is quite regular. But then for the wholesaler, you see already that there are quite some peaks here. And for the distributor, this becomes worse. So you see here the enormous amount of order sizes. And please disregard this fall. This is week 9, so we don't look at that. It's just decreasing to 0 because I have not played. And if you look then in the factory, that is really major. You see so that despite that the orders from the customer are quite regular, for the other supply chain partners upstream the supply chain, the orders increase in an enormous fashion that are not related to the orders of the end customer. Sorry. So this is just another depiction that shows you in another graph the same effect. Nothing else to add here. But maybe one thing. You will see here the name Bullwhip Effect. And this is a key term that you can also Google in the internet and read about it, because that is exactly what happens. So a little bit of orders downstream the supply chain can go up really a lot the supply chain. So if you don't know a bullwhip is a kind of a very long whip that is used to send cows or bulls in some direction. So it's a very long and very slight whip, and if you begin to give it a flow, let's say, in the hand of somebody. So this is supposed to be a hand of a cowboy or somebody. So a little movement here leads to go to the bull to this bullwhip to go up really high. So you have quite high oscillations, although in the beginning you just used a little bit of movement. So also what we see here in the supply chain, this is called the Bullwhip Effect, where the orders increase upstream the supply chain in an enormous oscillation or in enormous fashion. And please Google the term. You can read a lot about it on the internet, and it's quite interesting. So the next question is, what happened to the inventory if we look at our stock at the various supply chain players? For the retailer, we can say not much. We remember that inventories were quite for some weeks at zero, and well, at a certain stage they became also negative, so a backlog was building up, but things are still okay for the retailer, so the costs are not so major. But for the wholesaler, things look already quite different. So the backlog was building up at the wholesaler quite early in the beginning, and then they became really worse. For the distributor, it was even more drastic if you look at the backlogs that were building up. So backlogs is, for instance, another word for negative inventory. So we see here that the inventory depicted is negative, and this is what we call backlog. And for the factory, it peaked really in a negative fashion for the inventory. So the same if we look at the cost distribution. Sorry, this part of the graphic you should disregard because I just played until week 8, as I said. So I just have data until week 8. And you see that the costs are building up quite at an exponential fashion for all the players despite the retailer in the red line. So these are now questions that are noted and that you should be able to respond when you have played the online game and discussed it with your peers together. So the question is, did you feel at a certain stage controlled by forces in the system from time to time, or did you feel that you had the system completely under control? And while you were playing and discussing how much to order, did you find yourself at a certain stage blaming the other partners in the supply chain and the other group members next to you for the problems that you had in order to fill up your backlog and decrease costs somehow? This is more something that you will find yourself in when you are together in a room and playing at a table, of course, but also in the online version. There are things where you can experience something. So that is another question. Did you find yourself blaming the other partners in the supply chain? And when you go from week to week, did you feel some kind of desperation as well at any time? So these questions are somehow linked. There are more questions that you should discuss with your group members, and they are also interesting for the assignment. So for instance, first question, do you think that the setting of the game is somewhat unrealistic that is something just about a game, or would you say that this could exist also in reality, or is it something that we made up to show you some effect? Yeah, another question, why are there order delays? So why is it that we have these 2 weeks of lead time? Is that also something that we just made up, or could that be a realistic setting? And then also, why are there production delays and shipping delays? So these two questions are quite linked. But of course, they are on the different sides on the company level. So one is for the order delay. So you place an order at your supplier, but you also have delays in shipping your own items to your customer. So it's on both sides. So when looking at both the distributor and the reseller, for instance, why did they not order or ship directly from the factory to the retailer? So why, in other words, there need to be a distributor and a wholesaler? Why wouldn't it be just more easy if the factory and the retailer would work together in a collaborative fashion? Why do they need to be a distributor and a wholesaler in the middle? Yeah, and another question, must the factory be concerned with the management of raw materials and the suppliers of them? So should that be an issue as well in a realistic setting? So now let's compare these charts that I just showed you to the charts of other players that have played the same game. And you'll see here as well that things are quite easy for the retailer and still quite easy. And throughout all the weeks it seems quite okay. For the wholesaler, things already look a little bit different, and here they go down. So they are a little bit going into peaks, but if you see the distributor as well, then he peaks up also very much here with respect to the orders, quite close to a peak in the factory as well. And also here for the other players, you see that the factory order numbers, they really go up. And then things get quite quiet and under control again. But we can see already here some peak building up again in more weeks. So it seems that we have peaks building up in a kind of a wave fashion. And other groups look quite similar if you look at that, right? Here we have one peak, here we have different peaks, here we have one wave again. Here things a little bit more easy. Here we also have a big peak. And also here, well, the players were quite experienced, it seems. So one big peak and then things got under control again. But you see the picture is quite similar to different groups. Yeah, if we look at the inventory combined with the backlogs, then we see that if we have these peaks and backlogs or negative inventory, then we have a serious lack of service level, because we have to say to our customers that we can simply not deliver. And that is something that companies want to avoid at all costs normally. So they are rather prone to build up a high number of inventory than to create backlogs. But that means also that the total costs of the system will build up, especially for the factory, also for wholesaler and distributor, a little less for the retailer. Yeah, so please Google the term Bullwhip Effect. We have shown now some of the effects with respect to the inventories, and here to give it to you in a condensed fashion again. So the problem of the Bullwhip Effect is that it creates high inventory levels, higher than necessary. It creates, and this is linked, a low service level. That means back orders at a certain stage. Both of them lead to high costs, and this causes then also demand fluctuations upstream the supply chain, especially for the factory. So how does this come, or what do variation in demand mean for the different players in the supply chain? Well, the problem is, of course, within the capacity levels of each of the players. So we have shipment capacity levels, we have production capacity levels, and also inventory level capacities. So the space in a warehouse, for instance, is limited. So there is just a certain capacity that it can capture. And if this goes into waves, so it's building up and going down, etc., then this variation needs to be managed somehow. And well, one thing is we have looked now in time intervals of weeks. And this is quite a small time interval, let's say. If we look into months, then the decision can be to increase or decrease capacity levels of either shipment, production, inventory, and so forth. And if we have then waves in demand coming up, as we have seen just in the charter of the different groups, then this capacity will always go up and down. And it depends on how the contracts are managed, but this might not be possible to increase and decrease capacity just as the oscillation of the demand goes up and down. Yeah, and even if we can increase at peaks the capacity, most of the time, as we have seen with the backlogs, this capacity will be idle. So we have built capacities that we need to finance somehow, so they increase our costs, but they don't give us any kind of profit because the capacities are standing idle. So they are just generating costs. And in the end, if you look at the overall picture for all the players, we have overall high costs in the supply chain that are quite unnecessary because, as we have seen, the order levels of the end customers are quite stable. So there's no real explanation where all this oscillation comes from. Yeah. So if we look now we have considered a supply chain with just one partner in every time, in every stage of the supply chain. But if we consider that there are more than one, you can imagine how the competition increases in between the supply chain partners. So it's not just in between individual companies. So one thing is that it might be due to the structure of the supply chain that creates the behavior that we have just seen. So different people in the same organization and organizational structure can produce or will produce similar results, as we have seen also with the charts of the different groups that played. So the structure entails or induces a kind of behavior or process, so the oscillation that we have seen in the demands, and this leads to an event, and the event is, for instance, inventory stockouts, as we have seen, or extreme peaks in the order sizes, as we have experienced. So the real-world reaction to such a behavior would be in an organization a very human way of working. So you try to find a person responsible and a person that you can blame for the situation. So why is somebody ordering always too much? So this might be the inventory manager or the guy in production or the procurement manager who can be blamed. But this game that we have just played clearly demonstrates that this is a quite inappropriate response because different people react exactly the same in the same situation. So if you see these oscillations and variation in demand, then a necessary and a normal reaction to is to increase the order a little bit in order to have a kind of a buffer in case that the demand from the next supplier or from your customer increases by quite a lot. So this is absolutely normal. The question is now, if that is a normal behavior, how or could we change the structure of the system, so the system set up, in order to change also the behavior of the system. So the factors, let's look at the factors that contribute to the bullwhip effect. One we have already talked about a lot. One is the demand oscillation, and the thing that we can do to ease this is we can try to do a very good forecasting of demand. So we would use the aggregate and inaccurate data, or the data that we have looked at, the aggregated and inaccurate data, does not allow for a good prediction. So we need somehow to get a system where we can forecast the demand in a good fashion. Also because this high variability that we have in the demand needs continuous adaptation and an order policy that can help us to decrease the variability that we have seen in the upstream supply chain. So this is how we can deal, for instance, with the bullwhip effect. Another important and very important factor was the lead time. So every time you order, you need to keep in mind that it takes 2 weeks to come to you. So longer lead times lead to uncertainty, and that entails people to order too much. Also because you need to wait until deliveries arrive, so you want to increase your buffer just in case that a peak demand from your customer takes place that you wouldn't know about. And the lead time in that sense also reduces flexibility that you might have and adaptability to unforeseen changes in the demand. And this is why, you don't know how much will come, so you order more in order to be on the safe side. And that leads then to high stock levels. And the longer the lead time, the more uncertain the whole situation becomes. So order lead times are one major problem in supply chain management. Other factors that we have not seen so far or not talked about so far are batch ordering. So an order always takes place for a kind of a volume of items, and you might want to order larger batches at one stage of the supply chain. Because you have the lead time effect, and it might also, and we have not yet talked about it, this comes here, you might get a discount from your suppliers if you order more items. And this also, the batch ordering leads to higher variability than at your supplier side, because you order more than you actually need in order to get a discount, for instance. The price discount is mentioned here, by the way. And it might also decrease your transportation costs, because transportation costs normally pertain to one batch. And if you order larger batches but less frequently, then you get on one side a price discount, on the other hand you decrease your transportation costs. So that is why batch ordering is on the one hand good for decreasing costs, but very bad on the other hand when it comes to the variability of the demand at the next stage of the supply chain. price fluctuations that can accrue also to the price discounts that we have seen beforehand might also lead to the variation in the orders, because you might want to order more when prices are lower, so you increase your batch ordering to larger orders in order to get also, and here are the discounts once again. So you order more that you actually need in order to pay less, and that leads also to demand fluctuations upstream the supply chain. And all this leads to inflated orders. So we have seen we order more because of price discounts, we order more because of longer lead times, etc. And also in time that we might experience some backlog or shortages, then we are more due to, or we are more prone to order more in order to decrease the probability of having a backlog. So this is some kind of psychological thinking there as well. So lessons learned from this is that the traditional supply chain information about the customer demand is passed just along to the next supply chain partner through this ordering system that we place or the others place. And that might be based on forecasts, on aggregated figures of the items. So some kind of information is lost along the way, especially if you look at the retailer and the factory. They don't talk to each other. They have distributors and wholesalers in between. So they have actually no good, or the factory has no good idea about the real end customer demand as much as the retailer has. So the information is lost along the way. Buffer stocks are building up throughout the supply chain for no good reason. Well, the reasons that we've seen, the lead time uncertainty, the demand variability, but no real reason, because the information would be available within the supply chain about the real customer demand. So every player on its own, without talking to each other, so without communication, acts quite okay, or let's assume optimal for him or herself. But if you look at the overall supply chain, then this behavior is not optimal at all, and it results in higher prices and less sales overall, because demands cannot be satisfied throughout the whole supply chain. And then once again, remember that also we have competition in between the players, because the players are also acting not just in one supply chain, but in supply chain or in supply networks. So there might be competitors also along the way. Okay, and this was the theoretical part of the lecture. And now we would go to the questions. So the tasks and questions for the labs are now to make a discussion and discuss with your group members these 5 questions that you see depicted here. The good thing is that you can directly use them for the assignment 1. So please write them all down, because you can. These are the questions also for your assignment. So you do already now the work in your group together for your assignment. Yeah, and that was all. So thanks a lot for your attention, and see you in the lab sessions.